All right, so this is probably a new topic to anyone who hasn't already taken an Algebra 2 course. It's not really covered in Algebra 1, and that is something known as a logarithm. And a logarithm is basically just the opposite of, or the inverse. Inverse is another name for opposite. The inverse of an exponential function. So what do I mean by that? Really simple example. Suppose we had the following exponential equation right here. 2 to the third power equals 8, right? 2 times 2 times 2 equals 8. Another way of writing that, if you were writing this in terms of x and y, like 2 to the x equals y, remember that inverses are another way of saying opposites. So in the case of an opposite, you switch the x and the y. So here's how we could write this. We could say, and this is what a logarithm means. A logarithm means that you take the logarithm with a base of 2, you raise it to the third power, and it's equal to 8. It kind of makes this circle right here. This number raised to that power equals that answer. That's another way of writing, or I should say that's the way of writing the logarithm form of this right here. Okay, if you were doing this in terms of a general function, you would say the log base 2 of x is equal to y, because remember that we're supposed to switch the x and the y. So if you took this and switched it, you would have 2 to the y equals x. And now it's this base raised to that power, so raised to the y power, equals that answer. Okay, that is what we mean by logarithm form. It means taking an exponential function and writing it in another form. Just like if you were to write kind of a similar analogy, you could write x plus 8 as addition, or you could write it as x minus negative 8 as subtracting a negative, kind of like opposites there. Or if you said plus negative 8, it would be the same as minus 8. So let's practice. We'll do the first one in each category together, and then we'll see if you can pause the video and see if you can figure out the pattern. So remember, the pattern is it's always this number is the base. Let me write that right here. Actually, that number is the base. This number right here is the power, and this number right here is the answer. And that's how we write something in logarithm form. So this number raised to that power equals that answer. So we would say 12 to the second power equals 144, and that's all they asked us to do. They said rewrite logarithms in exponential form. Well, that's exactly what we just did. Alright, now down here, if we go the opposite way, so we want to now write this in logarithm form, we could say the following. We could say the logarithm with a base of 7, because that's the base right there. Let me do that in different color. Logarithm with a base of 7. Okay, and then we are raising it to the third power. So the power goes over here to the third power, and then it equals this answer. So the logarithm base 7 of 343 equals 3. Here's another way of saying this. Okay, here's what this kind of translates to mean, because it's a little bit confusing when you first see it. This right here, this expression, is another way of asking the following question. What power must I raise 7 to? What power must I raise the number 7 to in order to get 343? That is what we mean by a logarithm. Okay, so whenever you see log base a number of another number, that's another way of saying what do I have to raise that number to get that number right there? And the answer is 3. Okay, so let's take a look at this one, for example. This says what do I have to raise what do I have to raise the number 2 up to in order to get 8? I have to raise it to the third power. That's what we mean by logarithms. Alright, so hopefully you may have paused it and tried numbers 2 and 4. We'll do those together. So this is another way of saying what do I have to raise 18 to get 150? It will be 18, that number raised to that power equals that answer. 18 to the r equals 150, and that's what we need to do there. What power do I have to raise 13 to get 13? I have to raise it to the first power. So the log base 13 of 13 raised to the first power equals 13. That's how you would write that in logarithm form.